This is the Python file from the previous video I recorded, and it contains the insertion sort algorithm. And what I'm going to do is I'm going to add some subprograms to this. The first thing that I'm going to do is I'm going to look for the portion of the code that swaps two numbers. Now we recognize this as a type of action that we've had to repeat in many of the different versions of sorting that we've had. So it would be nice if we could replace this sequence of code with a bit of code that makes more sense. It's more meaningful. It matches the name that we used in our top-down design program. So in order for Python to know about a subprogram, it needs to have been declared before we call it. So up here towards the top of my program somewhere, usually you put things after you import. So the first thing you typically do in a program is you import the libraries, which are, by the way, full of other subprograms that other people have written. I'm going to define now my own subprogram, and in order to do that I use the word def in Python. That's just the way you do it in Python, right? So I'm now defining a subprogram, and I'm going to call it swap. And I'm going to list the formal parameters. So within the block of code that I'm about to write for swap, I can refer to the two things that I want to swap. Actually, in order to swap some values, I'm going to need an array, and I'm going to need the index of the first thing and the index of the second. So I'm going to take as my parameters array. Let me just call it, let me call it data. And let me call it index 1 and index 2. So now I have a declaration. So this is another compound statement. It begins with a header that ends in a colon, just like other Python compound statements, such as the while loop. After the name of this identifier, I've got an opening parentheses, and I've listed the formal parameters separated by commas. So now those are kind of placeholders. Those are names for whatever get passed in. So inside of this routine, I can do my swap routine. So I know data is an array, so I can say temp equals data at index 1. And now I can say data at index 1 gets set to what was stored previously in data at index 2. And now I can say the data at index 2 gets set to what used to be in data at index 1, and that was stored in temp. So now, whenever I want to swap two items of data, I can use this subprogram. It wanted me to put an extra space there, and so the problem is inside of this program, whatever variables I create, they only live in this block of code. So that's a thing about subprograms. There's this concept of variables scope. This name temp means something only inside swap. It's a different temp than this one down here, and Python is warning me about that. But it doesn't matter, because here, this is this same block of code, only instead of index 1, I'm passing index and index minus 1. So in order to call that block of code, I use the name swap, and then in parentheses, I pass in where the data is, right? In this case, I happen to have an array called data as well. And then the parameter, the argument that gets passed in to replace formal parameter index 1 is just going to be called index. So it has a different name. And then the argument that I pass in to replace formal parameter index 2 is just index minus 1. So these are the three arguments. And oh, it looks like data hasn't been allocated. Data equals 1, 2, 3, 4, 5, 6, 7, 8. Right? So I'm worried that this is a little bit confusing here, but what's happened is I have now created a new routine in Python. So whenever I want to swap two things, I can reuse this same routine, and then it'll go back and it'll execute these 3 lines of code, and then it'll return back to this line of code. I could show you that in a debugger, and But before I do that, I want to also take the entire insertion sort algorithm and I want to define that as a subprogram, because you can imagine there's lots of times you might want to sort different arrays, right? So I can define a subprogram called insertion sort, and it takes in an array, and that's all it really needs. So I'm defining now a subprogram and I'm putting all of this into that subprogram. Right. So this is now the insertion sort algorithm, and I'm going to define my two algorithms up there at the top, and then once those two subprograms are defined, then I can remember data here is just a placeholder. It could be referring to any array. So down here I can create a new array, but instead of calling it data, I could call it whatever I wanted to. I could call it foo if I felt like it. So my array is called foo, and this variable length is referred to by this subprogram, so I would rather make that be a parameter, length. What I'm trying to do is make sure that this subprogrammer doesn't refer to data that doesn't get passed into it. Right? So now let me actually call it. So I can create this array foo, and I can shuffle the data in foo. I can print foo, and I can call the insertion sort algorithm with foo, and for the length I can pass in the length of foo. And when it's sorted, when it's done, when that routine is done, foo should be sorted. There's a lot of possibly very subtle things that have gone on in here. So let me just try to review them before I step through the code. I defined a function swap, or a subprogram swap, and gave it 3 formal parameters. I defined a subprogram called insertion sort, and I gave it 2 formal parameters. All right. What I tried to do is I tried to avoid accessing anything in this program other than the data that was passed in through these parameters. Same in here. In insertion sort, if I needed any data, I tried to make sure it came to me as formal parameters. Within here, the names data and length are defined to be whatever gets passed in. Down here, I have a main chunk of code, and it creates an array of data, but it doesn't call it data. It has a different name, foo. And then I shuffle it. Right? Here I print what foo is on input, and here I invoke or I call the insertion sort subprogram. I pass as an argument the array foo. But when I'm here, when I start executing this code, that same array is going to be called data. So it matches the first one up to the first one. Okay. Again here, I call this method, which comes back, and it comes back with a number that's the length of foo, and that number itself is the argument to insertion sort. It's the second argument, and it gets matched up to the second formal parameter. So when I'm executing this code, whatever this evaluates to is going to be stored in this local variable called length. I'm doing some stuff for style. Python likes 2 blank lines in between. So let's run through this and see what happens when I debug this code. I'm going to put a breakpoint right at the top, and I'm going to hit the debug button. And I'm going to step through the code. And down here, we can see a couple of things. So these are the watches that I had set before. I'm going to get rid of those. And these are private variables. I wonder if there's a way to prevent it from showing those. Well, that was not the way to do it. Okay, so I'm going to begin stepping through the code now. I'm going to import random, and now I have a module called random, and inside random I have access to all of the data and methods that were defined in some other Python file. Now we're at this line of code. I'm going to step over it, and it's going to jump. It doesn't execute this block of code. That's really important. In the declaration part of a subprogram, the body of code does not get executed. It doesn't know what data index or index 2 is, so it can't execute this code. So it just sees that there is a method called swap, and then it skips over the body. So down here under my variables, I have a variable called swap, and it is a subprogram or a function. That's all I need to know about it, right? Same here for insertion sort. It sees that there is a method or a subprogram called insertion sort, but it doesn't process the code yet. We have not called it. This block of code will not execute until we actually call the subprogram and provide values for these parameters. So now I can begin this main chunk of code. It creates an array called foo, and it's the list 1, 2, 3, 4, 5, 6, 7, 8. I'm invoking another subprogram called seed, which sets up random number generation, and another subprogram called shuffle, which I imported from a library of functions or subprograms. So now I have my test data, and if I look at it down here, it's 7, 1, 2, 5. It's this shuffled array. I can print it, and it comes out here to the output console. I printed what foo was on input, and now it's going to call this insertion sort subprogram. In my debugger, if I just hit this button, it'll step right over that, but I want to step into it and see what happens during this function call. So step over, and it goes to line 30. But if I step into, it shows me that the next line I actually executes up here at line 11. So I'll step into it, and I can now see that my program counter has gone to line 11. Another thing that's happened is at this point in time, I can see that my local variables, the variables that are defined inside of this function, are shown in my debugger. And data is this list. Data is the same value as foo, and length has been set to 8, which is the value of the argument that was passed in. So these are now variables that are local to insertion sort. On my left, I can see a call stack. Right here, I can see the global scope, which has foo and my methods. But I'm not in the global scope. I'm inside of the activation record for the insertion sort function. And so I only have access to those local things. Initially, the only local variables are the parameters. And if I keep going through, I can add new local variables. So this creates one called current. And we're familiar with this algorithm. It'll execute as normal until it realizes it's time to swap data. Now previously, we had simply pasted this code in here, and it made insertion sort a longer program, and it also made it harder to understand insertion sort because you had to recognize that this sequence of 3 lines was actually swapping data. Because the name of the procedure tells you what's happening, using a subprogram is actually a self-documenting way to write code, and it helps you produce code that's clearer and easier to understand. And also, since you don't have to repeat this code as often, if I find a bug and fix it in one place, it's fixed everywhere. So you end up with code which has fewer errors and is more maintainable by using these subprograms. Now here I'm swapping, and I'm going to pass in data. So that's my local data, this one right here. And it's the same as the global one list called foo. So we've got a lot of names for the same data going on here. And when I step into it, there is a new activation record. So inside swap, I have my parameter data. That's different than the one in insertion sort. So it happens to be the same name, but it didn't have to be. I could have called this guy bar or something instead of data, and it would have referred to the same variable. So I've got data index 1 and index 2, and they've been replaced by the values passed in. So here inside swap, what do? I set temp equal to data at index 1. So temp is 1. Data index 1. So it's doing this swap. You guys are familiar with the swap routine. And when I'm done, it has indeed, it's swapped the 1 and the 7. and now I proceed to decrement index, and I'm out of the loop. So we can see that the routine should still work. I'm going to just hit the run button and look at the console, and we got 1, 2, 3, 4, 5, 6, 7, 8. So this routine works, except for that I've bundled up this entire set of code, and I've given it a handy name. So now whenever I want to insert stuff, I do my top-down design, but when I want to refer to insertion sort, I can just use this name. And this editor even lets me hide the body by clicking on the outline here, so that I don't have to worry about it. And in addition, I can see the structure of this file. It shows me my methods here. So this is just sort of how we organize our code by using subprograms. It has a lot of benefits, and it influences the way things implement, because as you saw right here when I called insertion sort, the next line of code that executed wasn't line 30, it was line 11. And when I called the swap routine, I didn't step into it, but I will now. So let me run this again, and I'll show you what happens when I call swap. Alright, so I just began the program. I'm up here, and I'm going to run all of the code. So I've gone here, I've called insertion sort, it's set current to 1, and it's entered this while loop, and it's just about to call swap. Right? I'm about to call swap. If I step into that routine, the next line of code, I wasn't line 17, and the next line of code that executes is 5, and then 6, and then 7, and at the end, after line 7, the next bit of code that executes, your program has to somehow remember where you were before, and that's kind of what's indicated down here. It remembers that you were in insertion sort at line 17, and that's where you're going to return when I execute this next line, or when I'm finished with this next line of code. So I execute that next line of code, and it returns. It returns back here to where the swap method was. It's possible to return value back, and you can see them here, but it didn't return anything. I'll show you what that means in a second. So so there we go. So wherever you call it from, it executes that block of code, and then it jumps right back to where you called it from. And that's what we were showing in that diagram. I'm going to make a new Python file really quickly. Call it sample.py. And I'm going to create a new function called add. And this is going to add two numbers. So I'm going to pass in some number 1 and some number 2. And the idea is that this program calculates the result is equal to num1 plus num2. So what I've done is I've created a new variable called result, and I've set it equal to the sum of those two numbers. But what this subprogram is going to do is it's going to return that value back to the caller. So the way data comes into a subprogram is through these parameters, but data can come out from a subprogram using a return statement. Right? So now, if I print the result of calling add with the numbers 4 and 3, what I should actually print is a 7. So let me run this program, and it displays a 7. So that's how you can write a subprogram that actually has a value. So if this subprogram, at the end of the day, you want to pass data back to your caller, so for instance the len function gave you the length of the array, then you have a return at the end. And that data, you can imagine that this whole thing just gets replaced by its return statement. So that's subprograms. I'm going to do another video about recursion that's going to blow your mind.